Welcome to the serverless focus session. I'm kind of curious, because of the type of event this is, how many people had to take a flight to join us here for Build? Wow. And how many of you took a direct flight? OK. So you had to make a choice. You can choose to take a direct flight or to take an indirect flight. And because so many of you took a direct flight, it sounds like you're familiar with the convenience. You only have to make it on time for one flight, and you only have to mind your luggage once. But if you take a connected flight, you have a few more things to manage, right? You have to make it on time for every flight. You have to mind your luggage. You have to manage your time in those airports. And maybe you have to pay for other expenses like meals. So why am I talking about this? I'm talking about this because it's a very good analogy for today's topic. Choosing serverless, it's almost like choosing a direct flight to your business goals. Not choosing serverless is almost like taking an indirect flight to your business goals. Both of those are valid choices, and you should arrive to the same destination. But there is additional management cost, and maybe there's additional risk associated with it. And maybe, just maybe, you have to be mindful about what your competition is doing. In this market landscape, the choices you make and the choices they make can affect your business. So let's talk about serverless. As you can see, there are a lot of people talking about serverless in the news. And that means there's great momentum in the market. That means it's a great time to get on board of this flight. So for this session, we will talk a little bit about what it means to run serverless on Azure. We will talk about the building blocks. And we will also talk about the serverless application lifecycle in Azure. We will focus on designing, developing, deploying, and monitoring serverless applications. So how many of you have already tried a function app in Azure? OK. How many of you have tried the logic app? OK. That's kind of what we expected. My name is Daria Grigoriu. I'm a senior program manager with the Azure App Service and Azure Functions teams. I've been in this team since the very beginning, and I really love this technology. But more than the technology, I love to see what people do to use it. And I hope that at the end of this session, you will choose to reach out to me and our team and let us know how this is working for you and how our team can help you reach your business goals. And joining me on stage is Yochay Kiriaty.
Hey everybody, thank you for coming. It's a full house. It's great. There's people still coming in. It's awesome. Thank you. Sorry for the late start. We had some network issues. We still have some problems. Anyway, long story short, thanks. My name is Yochay Kiriaty. I'm a program manager on the Azure team, specifically working on Azure Function. I've been working on Azure Function App Service for quite some time now, and we're very happy to be here to talk. Our team blogs a lot on blogsmsd and microsoft.com/appservice team, all the announcements, the latest Visual Studio tooling, App Insight integration, a bunch of other stuff, which is awesome. This is my Twitter handle. If you want my email, you can see it right there. And with that, I think we're moving on, right? Forward, not backward. OK, so let's go through it. Let's go through a brief, quick evaluation of the application platform, how we evolved and got to the point where we're actually going to talk to you about serverless. About half the room, raised their hand when we talk about that, so we'll see how we smooth the transition to everybody else. So we started on-premise, and we had hardware, and basically with the evaluation of all different platforms, there are optimization happening both on hardware and software. So with the hardware, we definitely saw a way that people are doing virtualization, and then they took this virtualization into the cloud, where we have basically IaaS. Then later on, we distanced ourselves even further, and we went to platform as a service, fully managed services, where you don't even manage not just the hardware, but you're not managing the OS, the patches, anything like that. And now we're moving into this serverless thing, which is basically giving you completely fully managed. You don't even care for the application and your platform that is running on there. You just write your function and it all goes there, all goes great. And with that in mind, basically, if you look at serverless, so fundamentally, when you look at serverless, in a nutshell, we basically abstract all the service from you. So it's a fully managed system, right? You don't do you have basically 0 administrative tasks to be able to manage any of your servers. It's all being managed for you. Your OS, the patching, the servers, everything that goes with it. Another fundamental another fundamental concept of serverless is that it's event-driven. What does it mean? It means if there are no events, if nothing triggers your function, nothing invokes your function doesn't run. And if there are some events, some of your function, well, all of the function run hitting all the events, and when there is a lot of events, then basically the system will scale everything for you. And it will just run as much scale as needed and be able to just absorb and run all the function, all the invocation for you. Coupled with the micro building, basically what happened is that you don't pay if there are no events. So you don't need a reserve capacity in advance, right? No events, you're not paying anything. Some events, you're paying for whatever is actually being run. And combined together, that's where the serverless and the powers comes together. And serverless is great, right? Because all of that basically allows you to reduce everything you do. You don't need to manage infrastructure. You don't need to manage your OS. You don't need to package the whole thing. So we are reducing your DevOps, and DevOps productivity basically increases and focuses only on what you need to build, which is basically just enabling you to focus on your business logic. You can go ahead and just drive and build your application. Literally from the first line of code, you're adding value and you're building business logic versus management aspect, or be able to handle a bunch of other stuff without serverless. And all of that together basically is making your time to market a lot faster, and it's all awesome. Okay, so on Azure, what do we got? So the application platform on Azure basically, application platform on Azure is composed of 2 main building blocks: Azure Functions and Azure Logic Apps. Azure Functions, as you would expect, is where you write code. You can define yourself and write code, and you can express yourself in JavaScript, C#, F#, and we have other languages as well in preview, and we're adding more and more languages. We have amazing developer tooling, as we're going to show you in some demos. Bindings and triggers are awesome with functions, and then the whole thing is open source, and it's all documented, so if you're really interested, go there. And Logic App are another amazing tools. Again, we'll see a demo later. Logic App is basically fully managed workflow, fully managed serverless workflow, orchestration engine for function and other services, has amazing visual designer, has 125 connectors, and works well with functions and any other data services. However, while you can do this for your compute aspect, you still need a whole platform actually to build an app, right? You need data, you need messaging, you need intelligence, you want to add bots, you need to do the whole thing. So to be able to have the whole package, Azure provide you this fully managed set of services that basically, together with the core serverless component of function and logic, gives you a full-blown kind of serverless architecture that you can build on Azure. It's fully managed for you. You don't need to manage any of the services or underlying infrastructure to make that work. As again, we'll see in some of the demos we're going to run. And obviously, Microsoft is being, from day one, a developer-focused company, and everything we have around the development experience for both function, logic, and the entire ecosystem is great. We have support for Visual Studio, local tooling, local debugging, and a bunch of other stuff that we'll be able to see later. All right, so what we've seen customers being using over the last year and a half that we've been working, we've seen a lot of customers, and these are some of the common scenarios that we see. Top left, you see the web version, which is a fully serverless web application. Daria will demo that we'll see a demo through the rest of the presentation. What we also see is a lot of what we call glue, cloud scripting, whatever you want to call this. A lot of companies are basically saying, hey, we already have an existing application. How we can slowly go into serverless? We don't want to rewrite everything. So glue is a great example of, hey, some event is happening here or there, and you basically add serverless slowly into your application portfolio to ease your way into it. Obviously, bots and AI that you've seen through the keynotes yesterday and today, a rising platform, a nuance, and there's nothing more easy than just basically integrate a function with bots. Actually, Azure Burst Service is built on Azure Functions. And IoT is another very common scenario where we see a lot of companies going into IoT because the nature of the serverless with the spikiness and the scale, you don't need to manage any infrastructure before, so it perfectly fits with IoT and a lot of streaming and all of that. So with that in mind, Daria will take you through a customer example.
You might have heard about Domino's in the keynote. For this particular session, we will focus on one way they use Azure Functions. Domino's has changed the way they move the data from their stores to their data warehouse. So what they do is they drop files from their stores onto an SMB share, and the presence of those files triggers Azure Functions to encrypt the data and move it to SQL. This is a great illustration of the serverless model because you see entirely event-driven compute, and you see this focus on the business logic. Also, the demand for compute is not constant throughout the day, so they can scale when they need to, and it's great that they only have to pay for what they use. We also learned that their demand for continuous integration aligns well with the model of Azure Functions because they can update their functions through Git check-ins. So we will look at a simple demo that we can leverage throughout the session for us to be able to illustrate the concepts that we need to cover. This is a simple pizza ordering app that will help us navigate serverless concepts throughout the session. You might ask, how can a simple app be useful? Believe it or not, it contains all of the building blocks that we need for a basic Azure serverless application. You can see that we have a web client. This is hosted in storage, and we will talk about how we use proxies with Azure Functions to access this content. You can see that we have the ability to order a coupon. Here we can provide an email address and request for a coupon to be emailed to the address we provide. Behind the scenes, our application is calling a logic app that orchestrates a workflow, requesting the coupon from a function app, and then calling into Office 365 in order to obtain the coupon. You can see we also have the ability to place an order. When we place an order, behind the scenes, the application is calling into a function app. This function app also connects with SQL in order to store the order that was placed. So we will take each component throughout the session, and we will explore how the application was created and what are the capabilities and the workflows that we use with these components.
Okay, so basically what you should have seen is a web application, a single-page application that is actually hosted on storage. And with specific proxies definitions, we'll show you in a second, you'll be able to see that we can actually have a Azure function proxy fronts basically anything, any backend URL, and you can host a single-page application from storage as an example. And then the order processing and the coupon processing, basically one goes into a function, the other one goes into a logic app. And again, we'll see some of those components how it come into play later through the other demos, assuming everything will work for us. So with that in mind, basically, when we go to do when we go to build serverless application, we walk through some specific lifecycle, like design, develop, deploy, and monitor. And basically, the rest of the session is focused on specifically those assets, and all the demos goes with that. So we'll start with design. When you come to talk about serverless application and design, the thing you need to remember is serverless is a distributed system by definition, right? Your app should be stateless, async, ideally for scaling. So you need to remember that when you run Azure Functions, one invocation can happen on one machine, the other invocation can happen on a different machine, and so forth. So you can bounce between all those machines. So you need to be able to design stateless and asynchronous solution to be able to scale, to take advantage of the fact that there's a event-driven programming model behind the scene that allows you to actually scale enormously. Obviously, you can connect with a bunch of other services, either Azure services or third-party services through trigger and binding on Azure, on Azure Functions, and with Logic App, you have connectors, so it's tremendously powerful. Figure out how do you want to use proxies. Proxies, as again, we'll show in the demos, give you the ability to expose a single API surface, and then you can manage multiple different backends, you can have multiple different functions or any other entities that you want to work with, which is, again, very powerful. Logic Apps, an amazing way to basically orchestrate workflow. You can orchestrate functions, can orchestrate other data services, works hand in hand with Azure Functions. Really a great serverless solution for managing workflows and accessing data services on-prem and through the cloud. And Logic App basically have a bunch of connections, so you can use all of that. And when talking about services in the cloud, obviously you need to remember the dev clouds, DevOps. So everything with automation around Azure Resource Manager, everything we're going to show basically are all Azure resources, Function App, Logic App, all the other components. Obviously, it's all built and designed around DevOps, so you can have multiple deployments, versioning. We enable slots on functions, right? Yay, we enabled slots a couple of days ago, so now I have slots, which is, if you're familiar with App Service, same concept, so you can have safe deployment. You can deploy, test it kind of in a pre-production environment on the cloud and be able to safely swap in between. And obviously, you can monitor and have alerts and very rich information with application insights. So moving on real quick, so triggers and binding. Triggers is basically what invoke your functions. They're also considered input binding, and then you have an output binding as well. And triggers and bindings combined together are a great concept because you can actually, with triggers, get data from the services that triggers you. You can use binding as an abstraction of data services where you write in and out data. So instead of writing to a queue, you don't need to bring the SDK, you just write directly and so forth. This is a partial list. We actually have more, and it's growing over time. OK, so for a very long time, Azure Functions was supporting scripts, whether it's JavaScripts or whether it's C# scripts. With the Visual Studio release yesterday of update 3 for Visual Studio 2017, and when they update Azure Core Runtime or Core Function something, what used to be the Azure Functions CLI, the local tooling basically, we have enabled the ability. This was already existing for a while, but now it's official and easy. Enabled basically for a .NET developer to use attributes notation, because what we have heard from .NET developers is that they are more comfortable with attributes versus going back and forth with the JSON. So what you see here is very simple. Hey, here's your function app, your function name, you can define it. What you would expect, you have attributes that are defining basically, for example, HTTP trigger is at a request. It maps to the JSON. You don't need to write the JSON anymore. We are doing the compilation of your function. You'll be able to, we are building the function JSON for you. Functions JSON is still required because we need it to support other languages as well. So here's the rec as an example, and you can use it as you would expect. And here are the queue. So there is an output queue here. As you can see, you define the queue name, the parameter you work with, the connection string. All of those information is again mapped to the to function JSON, which again being created for you automatically. All right. So with that, we'll see a demo of all of that of the local debugging. So we'll see the specifics. We said we'll skip some of the demo order. Next, I want to talk you through API abstraction and composition. So let's say you have a function app. Function app exposes an HTTP endpoint on function A. Let's say you have additional function app because you want to build kind of a microservices architecture. You want to be able to compartmentalize your application. You want to have different teams do different things. So you have function A and function B that also expose an API. Now, you don't want the client to be able to manage all of that. So with Azure Function Proxies, you can actually produce and show a single surface. You can expose a single API surface for your application. on function A in this example, which provide a single unified API surface to any kind of backend URL that you want to use. And there's a lot more that you can do other than just expose a backend URL. There is a lot of transformation that you can do and management of APIs. So assuming we have network.
Our demo application uses proxies. Proxies is a preview feature for function apps, and it allows us to do pattern matching on incoming requests in order to expose a unified API. Our demo app uses proxies for content, for coupon processing, so it's pointing to a logic app in the case of coupon processing, and for order processing, it's pointing to a function app in the case of order processing. You can see that we have access keys that we're abstracting away from the client by using proxies. And you can see also that we have the ability to repoint the backend if we look at how proxies are actually defined. For each proxy, we have a proxy definition that involves a match condition, where we can decide what kind of HTTP methods we want to respond to. And we also have the ability to rewrite parts of the request or parts of the response. The value of proxies doesn't stop with the unified API surface. You can also do versioning. You can also do things like mocks, where you might be able to enable development across the system by creating mocks, such as this one. So here, we can go and we can access one of our proxies, and we don't have to have an actual backend associated with it, but we have enabled development across the system.
So while Daria is setting up the workflow demo, which will hopefully work, it's partially local, right? We can show some of that at least, yeah. Hopefully. So Logic Apps. Logic App offer a serverless workflow orchestration for function and data services. And it's an amazing tool, basically, to go ahead and integrate with a bunch of stuff. It's a fully managed workflow as a service in the cloud. It provides you full control of all the flow. The designer is amazing, and the designer can do a lot of the stuff. A lot of workflow conditions, but there is a rich declarative language behind that supports this, that you can basically use that if the designer is not good enough or doesn't capable of everything you want to do. So there's a very declarative definition, persistent in between the states, really, really cool. And you can orchestrate not just function, but a lot of other data services. And this is important because this is just a partial list of much of the connectors that are available with Azure Logic Apps. And there are 125 connectors right now, but we're actually adding more and more all the time. And you can see here a lot of Azure names, but you can see a lot of third-party. So you can very easily connect to other services, other non-Microsoft services, and use them to be able to push data towards them, get data from them, whether it's FTP, Twitter, SAP, there's a bunch of Stripe here, Trello, Twilio, and a bunch of other stuff. As well, there is a whole set of slew of hybrid connections you can connect to on-prem. And basically, Logic Apps allow you to connect to literally everything. So you can connect to a lot of Azure services. You can compose function in between if you want to. You can connect to a lot of other third-party services. And you can connect to on-premise as well with the on-premise gateway. And for that, we're ready with the demo?
We mentioned our demo app uses a Logic app for coupon processing. This is a workflow that is very easy to see when we look at the Logic App Designer available in the Azure portal. Here you can see that we can add actions, and we can also add control flow elements like conditions. In this case, we're looking for a valid email in order for us to send the coupon provided by a function app to the address that was shared by the customer. It's very easy to add more elements to this flow. We can add actions, we can add conditions, and you can see, as we mentioned earlier, you have so many options to choose from as far as connectors that are available are concerned, so you can enable a wide variety of business workflows. This information that is represented as the logic app designer is actually persisted in a code view that you can also edit. And this is what enables mobility, and it enables us to have a much deeper view into how the concepts are abstracted. And we are ready to start talking about the development segment of our application lifecycle. For development, you have great local development options. We have the Azure Functions core tools, and these are used to be called the Azure Functions CLI, if you've tried it in that version. They provide the entire functions runtime running locally, and they can trigger from local events and they can trigger from Azure events. This is feature complete. The commands are established, so it's a great solid tool to work with. For JavaScript, Visual Studio Code is a great option. And for C#, we recommend Visual Studio 2015 or 2017 with our functions tooling. And we can have a look at what that can do when we're doing local development. So first of all, our new project structure is based on class libraries. You have the great power of IntelliSense and unit testing and everything that you're used to with Visual Studio. And we're introducing WebJobs attributes so that it's easier to convert from annotations to metadata that is required for our platform. There is a lot of value in the ability to do local development and debugging. Here, we have components of our demo, specifically the order processing function app and the client, that we can run locally in Visual Studio. Here we have our order processing function, and I've added a breakpoint that will allow us to interrupt the processing through local debugging. And we can get started with this locally by using the Azure Functions CLI. When we launch the local tooling, we have a custom MS build task that is running, and then the binary is picked up by our local runtime, and you can see we get a local URL that we can use to access this function. So we can also run our client locally. When we run our client locally, we are using the same URL that was provided by the function tooling. Here, we can place an order, and we can see we are hitting the breakpoint that we set earlier. Not only that, but we can override the request information. Here, I might want to override the email address that I was working with. And previously, I had just a generic email address. So I can make a change and show how that change takes effect. Here, first we can focus on the current value, personaid.example.com, and then we can override this value. And we can certainly see the change is taking effect. It's now localdebug@test.com. So let's continue. And once the order is complete, we can go and validate by looking at our database. And here we have our order number, and we also have the value of the email address that we managed to override during our local debugging session. the value of the tooling continues also through familiarity, because you can do all the things you're used to doing when you're running with Visual Studio, such as being able to do simple publish directly to Azure by doing a right-click publish. All right, so you might say, okay, what if I'm not writing C# code? Well, if you're running Node.js, for example, you have great features that are similar to what you've just seen in Visual Studio Code. We support Node 6.5.0, and VS Code by itself has support for local debugging, but we also have the CLI for functions so that you can get a similar experience to what you've witnessed here. So now we can also talk about the deployment aspect. When we talk about deployment, we're talking about a few different topics, so let's explore them. The first one is resource deployment. In Azure, function apps, logic apps are represented as resources. So a great, consistent, and automatable way to deploy resources is by using the Azure Resource Manager, or ARM. And we use ARM templates to deploy. And then once you deploy your resources, you can deploy content, or you can do it at the same time. We have great options for that as well. So you can use Visual Studio, you can use the CLI, or Azure Functions Core Tools, and you can also expect continuous integration to work just like you're used to. In addition, there is a safe deployment practice that we talk about in Azure, and that is separating your production from your development environment. This is especially relevant for serverless because it's an event-driven programming model. So it's really important that you control who processes your events, and also that you control isolation for production so that you're not deploying over code that is currently reacting to events. And what we advise for that is using deployment slots. Yochay mentioned that it's a feature of Azure App Service that we just opened up for Azure Functions this week. So when we talk about function apps as ARM resources, they are very, very similar to what you're used to as app service resources. They only have a couple of things that are specific to them. One of them is you have to specify the kind, and the other one is that you have a set of app settings that are very specific to functions, and what they do is they describe the dependency to Azure storage. So I'm going to be brave, and I'm going to try another demo. In the context of deployment, we talked about function apps being ARM resources. Logic apps also have an ARM representation. You have the ability to work with logic apps in Visual Studio tooling. You can see the same logic app designer view here that we are used to seeing in Azure. Not only that, but you can edit that view. And the way changes are persisted are through ARM template formatting. So here we can define our entire set of resources, and we can expect these resources to be deployable to Azure through the ARM or Azure Resource Manager. With this tooling, it's very easy to do that type of deployment. Let's say that we would like to deploy our entire logic app. And all we have to do is do a right-click deploy. Visual Studio is connecting to the subscription in Azure, and it's able to enumerate resource groups so that we can select a resource group for deployment. And once we select a resource group for deployment, we can go and watch the resources being created. So I'm selecting the resource group, I'm selecting the deployment template, and I'm selecting a set of parameters that should be applied. These parameters can be edited. So here I'm editing the name for my function app. And I will request deployment. We have this resource group that is currently empty. And we can watch for resources to start being populated in this resource group that I selected. So if we continue to refresh, we will see these starting to be created in real time. And we might not watch for all of them to be created, but you can see how they're starting to come in. So the next thing that we wanted to show you today was how you can publish from Visual Studio. And one way that you can do that is right-click Publish. It's the same concept that you might be used to already. We also wanted to talk about how deployment looks like when you have deployment slots in the picture. We talked about deployment slots as a safe deployment practice. Here we have our coupon processing function app, the same that we've been exploring throughout the session. We have a production deployment slot, which is the one that you're used to. And also we have a staging deployment slot configured. The staging deployment slot is a standalone application that can be managed, configured, and addressed individually. So we will look at how we can do a swap deployment and what it looks like to configure slots. First, we will look at the result that we are currently seeing from our production slot when we ask to retrieve a coupon. If we request a coupon, we are told no coupon offer is available at this time. So here we can make a change and request for the coupon value to be returned as a free t-shirt coupon. This is integrated with GitHub, so we're going to commit our changes and expect our staging slot to be updated with this change. So this is our git commit. And if we go back to the portal view of our staging slot, we can see here that we have this connected to GitHub. Not only that, but we can see our deployment history, and we can see progress for syncing to our latest commit. For this, we use our Kudu engine in Azure, and we are listening to a webhook configured to GitHub. We're pulling in the changes, and we're also doing a local build on our Azure machines. And this is great because you have opportunities to build on the same environment that you were planning to run your code in, which is always a good idea. So there we go. We are notified that our changes have been deployed to this staging slot. And we can validate this by going and requesting a coupon from the staging slot. And we expect the value returned to be, you get a free t-shirt, and that's what it is. So now that we validated our changes, we're ready to go back and request a swap. So that means that we're swapping between our staging slot and our production slot. And this swap operation is available here under the function app overview. And we can say that we want to swap from staging to production. And then we will be notified when the swap is completed. One thing to point out here is that you have the ability for your staging slots or for slots in general to be configured differently than production. So if we look, for example, at application settings, here what we see is that we've defined what we call a sticky app setting. It's a storage connection in this case, and you can choose to define such app settings that will be in variant across swap. They will stay with the slot where they have been configured. You also have the ability to diff these app settings. So there are a lot of features that are already available to help you with running deployment slots with Azure Functions. We were notified that our swap was completed. So now we can go back to our production slot this time, and we can request the coupon again. And there we go. We have deployed our changes, and now we get a response that our coupon is a free t-shirt.
All right, so the next thing we want to talk about is monitoring. And monitoring basically starts with the ability to monitor. So you need to be able to monitor your serverless application. Once you're monitoring, you may want to go ahead and generate alerts. Nothing works today. Generates alerts, and so you're monitoring your alert. You basically learn. You learn from the telemetry that comes in. You learn from the alert. You learn how to actually run and manage your application, and then you want to optimize. And then there's a cycle that goes through, and ideally with continuous deployment integration, all of that makes things a lot easier. Cool thing is with Azure Functions, we have integrated App Insights directly into the platform. So App Insights, Application Insights, I don't know if you guys, how many of you guys are using App Insights? All right, so most of you are familiar and know what we can do. So great news, when you create a new function today on the portal, you can check a checkbox and says I want Application Insight enabled and deploy with it, and you have App Insights deploy with your Azure function, which is awesome. Give you rich telemetry and data, all of that. There is specific setup within the functions.json for on Azure Function to be able to control some of the telemetry information and error level and all debugging information you want to produce, or basically telemetry you want to externalize to App Insights. And the App Insights portal and all the tooling will give you great indication. So we'll brave another portal demo.
Our demo app is integrated with Application Insights for monitoring. We are creating custom events when we process coupons and when we process orders. And here with App Insights, you have a great overview of both platform metrics and the custom events we defined as part of developing that application. In this case, the custom events are processing orders and processing coupons. And then we'll zoom in to make that a little easier to see. Not only that, but we have the ability to run queries against the data that we create. So here you have a better representation of the trends as far as coupons and orders being processed. And not only that, but in this case, we have some random failures that have been introduced throughout the app execution. And you can see here that you have this opportunity to look even deeper into the data and have integrated diagnostics as well, which is a very useful feature to have. So this is a great view to explore by integrating with App Insights and then looking at a rich view of the data and metrics that are retrieved.
Okay, and with that, we're going to go in and pass the torch to Andrew, which I'm going to show you basically how you can run Azure Function Runtime on-premise, and I assume that might work better.
I've just got up on stage and saw a battery warning, so let's hope so. Good afternoon. Yeah, yesterday we announced the Azure Functions Runtime preview, and this is a way that you can get the power of Azure Functions, but with inside your on-premises network and your own infrastructure. So from a developer experience, we support the same consistent programming model which you're used to when you're working with Azure Functions in Azure or on Azure Stack. The same functions portal that you've come to know and love. And we have, obviously, because of our great experience with Visual Studio and the experience that you have today from a development tooling, we have the publishing capability from there. We've brought a new trigger for Azure Functions Runtime, and that's SQL Service Broker trigger. You won't see HTTP triggers or generic webhooks because there's no HTTP endpoint exposed. The Azure Functions workers run inside containers, and for that reason, you will need to run on Windows 10 Creator Edition or Windows Server 2016. But the benefit of this model that we think we're excited to see what you do with it is many, many organizations have thousands of PCs sitting running overnight doing absolutely nothing apart from consuming power. So why not turn those into functions workers and have them doing some high-power compute and taking advantage of your spare compute? The management role hosts our portal and our publishing endpoint, and then the worker roles do all of the work for you. But that's enough talking. Let's have a look at a demo. So here we have the Azure Functions Runtime portal, the same portal that you're used to seeing within Azure, but we've shipped it on our management role. And we have language support in the preview for C# and Node.js. And you'll see here that I have a output queue trigger that's looking at an Azure storage queue. So what I've tried to do is take the demo that Daria was working through, and I have the same pizza application. And in this instance, we're not persisting the data to a database inside the cloud. We're just putting on a queue for processing. So I'm going to go off and get me a coupon, wait for that to go and call. This is a combination of a hybrid. So we're talking to some Azure functions, and then we're talking, we're going to close up the demo with Azure Functions Runtime. Is that going to come back anytime soon? No? OK, let's just create the order and hope that goes through. Please. Oh, no. OK. Let's try once more, and if this doesn't, there we go. Morning special, get Azure Functions Runtime. Let's place the order. We now have an order placed on my queue. And we now have a line of business application that simulates what would happen, say, in the pizza shop where we need to actually fulfill this order. So in the background, our function is polling and making sure that we can reach that storage queue. You see the logs coming out at the bottom. See it pick up the message. Do the old faithful and just check the messages there. So there's the message, just waiting for it to be picked up. Looks like the demo gods are not shining on me either. Let's do a refresh, see if we pick up the order. Well, here's an order from earlier. So in true Blue Peter fashion, here's one I made earlier. And there, that order was pulled in to my SQL database on-premise, and I read it through my line of business app, and now I can change the status inside my organization. So this kind of example shows how you can produce a hybrid app to take advantage of Azure Functions and working with multiple services where you don't want data at rest, or whether you can use Azure Functions on-premise to do some processing which you need to take care of. So this way you can integrate Azure Functions with ERP systems, et cetera, which you can't expose externally, and you can use the power on-prem. We're really excited to see what you do with it, and we've already started to see some suggestions and some issues flow in on the blog posts and on GitHub. So we're really excited to see what you do.
Hey, Andrew, one question. Can you switch to the portal real quick?
Yep.
Can you explain where this is running from?
Yeah, so this portal is all running on-prem, and this VM that I remoted onto is a machine that we have running in CorpNet. So if I open up IIS, oh,
the log just got updated.
but I think the powerful thing is to show the container. So there we see it's running, but if I scroll up, we'll see there in the Docker server, I haven't got zoom it on this machine, but we can see in the trace that we're starting up a container for the function, and on this instance we have two workers available, and we'll spin up multiple containers to run the function's workload in. Everything's running on-prem, everything's local to your organization, nothing is reaching external unless you ask it to. And now back to Yochay to wrap up.
All right. So terrible apologies about the network and the demos issues, but I hope you got somewhat of a sense of what Azure what serverless on Azure can offer you. There is a pretty rich set of services that you can work with. Use binding, use local developer tooling for basically to optimize your time to market and to just enjoy development. Logic apps are great. You can try Logic App and Azure Functions on AKS Try Functions. You can join the community. There is a session tomorrow. Chris and Donna will show the developer experience. I truly hope they have better luck than we are. And please come and see us at the booth upstairs, or not upstairs, actually downstairs. See us at the booth for Azure Functions. And again, we'll show you some cool demos there as well. Thank you very much.